Stress fractures result from low-magnitude forces sustained on a repeated basis. One of the most common injuries in adolescent runners is the tibial stress fracture, a small crack in the tibia that develops gradually from constant weight-bearing activity. Most researchers agree that tibial stress fractures are caused by repeated bending of the tibia. Much like a thin steel rod under a compressive load, the tibia bends slightly on impact with the ground. This compressive load has the effect of three-point bending, causing the tibia to bend slightly forward in the sagittal plane. When bending is present, the structure is loaded in tension on one side and in compression on the opposite side. Because bone is stronger in resisting compression than in resisting tension, the side of the bone loaded in tension will fracture first. The fracture usually occurs on the distal third of the tibia, where the bone is narrowest and most susceptible to bending. Normally, this repetitive loading doesn't cause any problems. That's because healthy bones have an ability to remodel according to the stresses they experience in everyday life. Any increase in the magnitude or frequency of bone loading produces a stress reaction, which may involve microdamage. Bone responds to microdamage by remodeling. First, osteoclasts resorb the damaged tissue, which is shown here in red. Then, osteoblasts deposit new bone at the site. The problem arises when the bone is not allowed to rest long enough for osteoblastic bone generation to occur. Osteoclastic reabsorption increases bone porosity, reduces bone mass, and decreases bone strength and stiffness. Hence, the strain on the remaining bone increases. In healthy athletes with adequate rest, the lost bone is replaced by more dense bone so that the stress site is strengthened. But when there is not time for the repair process to complete itself before additional microdamage occurs, the condition can progress to a stress fracture. Stress fractures begin as a small disruption in the continuity of the outer layers of the cortical bone, but can worsen over time, eventually resulting in complete cortical fracture. In runners, a group that is particularly prone to stress fractures, about 50% of the fractures occur in the tibia. Increases in training duration or intensity that do not allow enough time for bone remodeling to occur are the primary culprits. Other factors that predispose runners to stress fractures include muscular fatigue and abrupt changes in either the running surface or the running direction. Thanks for watching and have a great Thanksgiving.